Hello students, welcome back to your YouTube channel Mathematics for Everyone. In this video, we shall take equivalence classes and the questions relating to reflexive relation, symmetric relation and transitive relation, equivalence relation. First of all, equivalence class. Equivalence class. An equivalence relation are an equivalence relation are defined on a set A, defined on a set A, divides the set A, divides the set A into pairwise disjoint sets, into pairwise disjoint sets. Pairwise disjoint subsets, subsets, subsets. These subsets, these subsets are called equivalence classes. Equivalence classes. Determined by relation R. Determined by relation R. So this is equivalence relation, and equivalence relation are defined on a set A, divides the set A into pairwise disjoint subsets. These subsets are called equivalence classes determined by relation R. Now let us take questions based on the different types of relation. First question, first part. First question, determine whether whether each of the following relations each of the following relations are reflexive, symmetric or transitive or transitive. First part, first relation is relation R in the set A. Relation R in the set A is equal to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Defined as R is equal to xy such that 3x minus y is equal to 0. Solution: we have R is equal to xy such that 3x minus y is equal to 0. Therefore, 3x minus y is equal to 0, y is equal to 3x. Now, A is 1, 2, 3, 4 up to 14, 13, 14. By taking these values of x and y, we can find out R. Therefore, R is when x is 1, y is 3. By putting in this, x is 2, y is 6, x3, y 9, x4, y 12. We cannot take x is equal to 5. Why? Because the y will be 15, which does not belong to this. Now from this you can see since 1, 1, 2, 2, 3, 3, so on, 14, 14 does not belong to R. Therefore R is not reflexive. R is not reflexive. Then next we can check symmetric. Symmetric. Now let 1, 3 belongs to R. 1, 3 belongs to R. 1, 3 belongs to R. Since 3, 1 does not belongs to R, as 3x minus y is equal to 3 into 3 minus 1 is equal to 9 minus 1 is equal to 8 is not equal to 0. Why? Because 3x minus y is 0. Since this is not equal to 0, therefore 3, 1 does not belong to R. That means R is not symmetric. R is not symmetric. Then we take transitivity. Now let since 1, 3 belongs to R, 3, 9 belongs to R. Since 1, 9 does not belong to R, as 3x minus y is equal to 3 into 1 minus 9 is equal to 3 minus 9 is equal to minus 6, which is not equal to 0. Therefore, R is not transitive. So we can check in this way by taking any values. Then we take second part. Second part, relation R in the set n of natural numbers relation R in the set n of natural numbers defined as R is equal to xy such that y is equal to x plus 5 and x is less than 4. Solution: we have R is equal to xy such that y is equal to x plus 5 and x is less than 4. This implies x less than 4 means x is equal to 1, 2, 3. And we have y is equal to x plus 5. Therefore, R is when x is 1, y is 6, x is 2, y is 7, x is 3, y is 8. As per this equation by putting these values. Now since 1, 1, 2, 2, 3, 3 does not belongs to R, so R is not symmetric. Now 1, 6 belongs to R. Since 6, 1 does not belongs to R. Why? As we can put these values in this. Y is equal to x plus 5 means y is 1 is equal to 6 plus 5. 1 is equal to 11 is not true. Therefore, R is not symmetric. Then we take transitivity. Now 1, 6 belongs to R, but there is no other ordered pair in R which makes x, y belongs to R, y, z belongs to R, implies x, z belongs to R, true. Therefore, R is not transitive. Then we take third part. Third part relation R in set A. Relation R in set A is equal to 1, 2, 3, 4, 5, 6 as R is equal to xy such that y is divisible by x. Solution: we have r is equal to x, y such that y is divisible by x. Now, x belongs to R. X belongs to R as x is divisible by x. X is divisible by x. Therefore, R is reflexive. R is reflexive. Now, 1, 2 belongs to R as 2 is divisible by R, divisible by 1. But 2, 1 does not belong to R as 2 is not divisible by 1, divisible by 1. Therefore, R is not symmetric. R is not symmetric. Then we have now 1, 2 belongs to R, 2, 4 belongs to R, as 2 is divisible by 1, 2 is divisible by 1, and 4 is divisible by 2. 4 is divisible by 2. Now, 1, 4 belongs to R, as 4 is divisible by 1. Therefore, R is transitive. Now here you can see R is reflexive, but R is not symmetric. R is transitive. Next, fourth part. Let us take fourth part. Relation R in the set of all integers. Relation R in the set of all integers. Relation R in the set of all integers defined as R is equal to xy such that x minus y is an integer. X minus y is an integer. Solution: we have R is equal to xy such that x minus y is an integer. Since x minus x is equal to 0 is an integer, therefore x belongs to R. Therefore R is reflexive. Now xy belongs to R, means x minus y is an integer. Since y minus x is equal to minus x minus y minus this is x minus y is an integer, therefore yx belongs to R, therefore R is symmetric. Now let xy belongs to R, yz belongs to R. That means x minus y is an integer and y minus z is an integer. This implies x minus y plus y minus z is equal to x minus z is an integer as sum of integers is an integer. That means xz belongs to R. Therefore R is transitive. So here R is reflexive, R is symmetric, and R is transitive. Thank you. In the next video, we shall take more questions relating to reflexive, symmetric, transitive, and equivalence relations. So please don't forget to like, share, comment, and subscribe to your channel Mathematics for Everyone. Thank you. See you in the next video.